Okay, YouTube, in this video we're going to be looking at probabilities of independent events. And as I have an independent event example here, what I'm going to do is I'm going to tell you that I'm going to add in a dependent event example. And so let's go ahead and extend our title here, probability of independent and dependent events. And so the first thing we're going to do here is we're going to define what we mean by independent events. What do we mean by that? And so looking in this first box, we say if A and B, if these two things are independent events, then we say the occurrence of one has no effect on the occurrence of the other. And the probability that both A and B occur is basically this. We say probability of A and B is then just the probability of A times the probability of B. So in the last video, when we looked at rules of probabilities, we said probability of A or B. That was implying addition, probability of A plus probability of B minus anything they had in common. In this video, we're going to highlight the fact that when you have the probability of A and the probability of B, then what we get is a probability of A times the probability of B, and it implies multiplication. So this is what we refer to as our multiplication rule of probability, multiplication rule. And we use it when we talk about independent or dependent events. Now, remember we said dependent or independent events. Independent means that the the occurrence of one does not affect the probability that the other one occurs. And so what I can give you is, an example of dependent events, dependent examples. I suppose that if you were to look at two things that are occurring in sequence, I suppose I would say studying, and then grade on a test. Those things, if you were to study, it would affect the probability you get a better grade on your test. Or if I were to say train for a race and the probability that I win. Doing more of this is probably going to affect this probability here. When we talk about independent events, these are things, independent examples, and I apologize for the handwriting, but independent examples are things like flip a coin, then roll a die. And the thing here is this: when you flip a coin, flip it, it's not going to affect the likelihood that this die lands on anything. These are not cosmically connected events. And so when we talk about independent events, the probability of A and B, we're really referring to two things that are occurring in sequence. So we're going to make a little note here. With respect to these events are occurring in sequence. You can look at it as in order of time, okay? And also we would say that these two events right here, A is the first event to occur, B is the second event to occur in this particular instance here. So I'm excited to use this multiplication rule. Let's go ahead and take a look at an example right here that most would call a word problem. But basically, let's take a look. It says a sales rep makes a sale at approximately 1/3 of all calls. So we'd say 1/3, that's kind of like the likelihood that she or he makes a sale on any of these given calls at random. So we say if on a given day the rep contacts 5 potential clients, we say what is the probability that a sale will be made with each of the 5 contacts. So now my first rule is always write down the probability you want to find. So what I'm going to do is this. I'm going to say 5 sales in 5 calls. What's the probability that I get 5 sales in 5 calls? But what I want to do is I want to kind of interpret this a little bit different. What I'm going to do is I'm going to say this is the probability of a sale, and then the next one is a sale. Get a sale on the next call, and then you get a sale on the next call, and then you get a sale on the next call, and then on your 5th call we get a sale. So you can see why I avoided writing it out this way in the first place. But when you talk about things that say, okay, well, you made 5 calls and all 5 of them were sales, what we're saying is those things happen in order. And so essentially what we're going to get is this. We're going to rewrite this in every instance of the word, and we're just going to make it a multiply. So we're going to say really this is the probability that we get a sale on that one times the probability we get a sale times the probability we get a sale. And this just goes right across the board. So when we have repetitive things like this, where the probability doesn't change, what we instead end up doing is saying, well, the probability of a single sale is 1 out of every 3. So I'm going to put in for that probability its value, and I'm going to say that really I just get 1/3 times itself 5 times. So doing an example like this is actually quite useful. One, because it shows you that we can just multiply all these individual probabilities together. And we get 1/3 to the 5th here, which is 1/729, I think. 3 to the power of 5, 243. So 1/243, we'll get a decimal here. We say 1 divided by 243. about 0.00412, so approximately 0.00412, and then out to 4 decimal places here we'd have a 0.412. That's good enough right there, but percent chance of this occurring. Essentially though, what I want you to know is that we could say if this is going to happen times itself many times, we could say that really this is the probability that we get a sale 5 times in a row, which is really the probability of 1/3 to the 5th power here, which leads us to this example's answer right here. So what I'd like to do before we piece out of this video is consider this. What if I were to have events that were independent of one another, or sorry, dependent of one another? So we say dependent. We looked at an independent events example. We say dependent events. You know, let's kind of type this out here. What if I were to say in text, find the probability that 2 kings are drawn from a standard 52 card deck without replacement. I'll put a comma there, Oxford comma, without replacement. And that's the thing, you'll see this every once in a while. And what that basically means is, oh, okay, I want you to consider your deck of cards here. If we're saying, first of all, write your probability, which is what we want to do. Find the probability that we get 2 kings. I'm going to write that. We say probability 2 kings. Now, I want to resist this and actually go with the urge to write a king. Whoops, I didn't mean to write the 2. We say probability of 2 kings really means a king, and then I'm going to write what I really mean here, and then another king. And that word and right there, this is what we're going to focus on. That word and essentially is implying that we need to multiply these. So what we're going to get is this. We get the probability of a king times the probability of a king. And the thing here is this. The probability of a king on the first draw is going to be a 4 in 52 chance. So we say the value of that probability is 4 out of 52. Now the probability of a king on the second one, the key word here was without replacement. And so because we did not put the first king back, what's going to be different essentially is this. Instead of having 52 cards in the deck, we're going to have 51. And instead of having 3 kings in the deck, we're going to have 3 remaining. So we do need to think these things out here. As a matter of fact, let's go ahead and reduce these. We say 4 over 52 actually reduces to a 1 in 13 chance here. And 3 in 51, I hate to point this out, this is a 1 in a 17. So multiplying straight across, we would get 1 times 1 over 13 times 17, which I do need to go find a value for here. But we say 13 times 17, we get 221. So it's a 1 in 221 chance, which we do also want to get a decimal for here. So we get our calculator out again. We'd say 1 divided by 221 is about 0.00452, so 0.00452, which is also approximately 0.452%.